Hello everyone, and welcome to another math tutorial. Today's tutorial is going to continue with our study of circles. We're going to be talking about arcs of circles. In this video we'll talk about how to find the measure of an arc and how to identify if two arcs are congruent. Before we can talk about arcs, we have to first talk about what creates an arc. There are a couple different kinds of angles that can be created or formed inside of a circle, and the one that we're interested in today, how we create arcs, is from central angles. A central angle, and there's one pictured right here in this circle. A central angle is an angle whose vertex is at the center of the circle. So recall, in order to have an angle you need a vertex and then two rays originating from a common vertex. So if the vertex of that angle is at the center, you have what is called a central angle. Now, in this diagram, if we trace out the sides of this angle, so we have side AC and we have side BC, you notice that those two sides are intercepting the circle, okay, at two places respectively. Now, what that does is it divides the circle up into two arcs. An arc is basically, it's part of the circumference of the circle. Now, arcs can be classified two different ways. We can have minor arcs, we can have major arcs. The association minor or major references the size of the arc. A minor arc is one that is less than 180 degrees or half the circle. Okay? We name minor arcs with two letters. Those two letters are the beginning and end point of the arc. And the way we name it, the notation we use, if we're going to name this arc AB, is we simply use the letters A and B, the beginning point and the end point, and we put an arc shape above those two letters. Now, in contrast to a minor arc is a major arc. A major arc has to be greater than or equal to 180 degrees. So it's more than half the circle. Now, when we name a major arc, we're going to use three letters. We're going to use a start and end point. But also you're going to need a middle point, okay? Because if I just say we're starting at A and we're ending at B, well, I'm not going to know if you mean to go this direction around the circle or if you mean to go this direction around the circle. So the way that we combat that is we're going to use three letters. We're going to use a start point and an end point, and we're going to use a point that the arc goes through. Okay, so it would look like this. This arc starting at point A, ending at point B, but going through point D would be written A, D, B. So there's the difference in the two names. Two letters means it's a minor arc, means it's less than half the circle. Three letters means it's a major arc, means it's more than or equal to half the circle. Okay, let's dive into some example problems. Directions for all these problems are to find the measure of each of these arcs. When you find the measure of an arc, the measure of an arc is the same as the measure of the central angle that forms that arc. So what I would do first, if I have a series of arcs that I'm trying to find the measurement of, and I have a circle here, the first thing I would do is I would mark the value of all the central angles that I see here. So RT is a diameter, which means this has to be 180 degrees together. So that means this angle here needs to be 70 degrees, so that 70 plus 110 makes my 180. And then of course the other angle is the other half of the circle. It is going to be 180 degrees. All right, now let's find the measure of all these arcs. The first one, RS. RS is starting here at R and going around to S. The measure of RS, and if I want to indicate measure, the way I do that is like this. I'm going to say little m means measure, RS, like that. And the measure of this arc is the same as the measure of the angle that forms this arc. So it's going to be 110 degrees. The next one is RTS. So RTS is going to start at R and end at S. It's going to go through point T on the way from R to S. So RTS is going to be this arc, goes all the way around that part of the circle. So the measure of RTS is going to be the combination of this central angle 180 and this central angle 70. So I'm going to add 180 plus 70 and get 250 degrees. The final arc, RST, so that starts at R, goes through S, and finishes at T. The measure of arc RST is going to be the combination of the 110 degree angle and the 70 degree angle, which is half the circle, 180 degrees. Okay, next example problem. Same type of problem. I'm going to begin first by finding this missing angle here. And once I have all the central angles found, then I'll start finding the measure of these arcs. Now I know a circle in total is 360 degrees, so that means that this angle right here has to be 360 minus 110 minus 80 minus 40. So that's 360 minus 230, which makes this angle 130 degrees. From there, we're ready to begin. The measure of arc GE starts at G, ends at E. That's here to here. That's the combination of these two central angles. So the measure of arc GE is 40 plus 80, which is 120 degrees. The next one, arc GEF, is going to start at G, go through E, all the way to finish at F. Measure of arc GEF is going to be the three angles that combine to give us that arc. 40 plus 80 plus 110, that's 230 degrees. And finally, arc GF. It's a minor arc that starts at G, goes around the circle to F and ends there. We found that central angle at the start of the problem. The measure of minor arc GF is going to be the measure of that central angle, 130 degrees. Okay, this next example problem is one that you can try on your own if you wish. Go ahead and pause the video, write down the problem, take as much time as you need, and when you're ready to see the solutions, just resume playing the video. All right, so I'm going to start by finding all the central angles first. Note this information right here, AC is perpendicular to BE. Right here, that makes each of these two central angles 90 degrees. Angle AED has to be 180 minus 40, makes this angle 140 degrees. All right, so with all the angles found, we can now start to find the measure of all these minor and major arcs. The first one, AB, the measure of arc AB, we have the angle already. It's 90 degrees right here. Second one, measure of arc ABC. So go through B, and end at C is going to be the 90 plus 90, these two angles right here. Measure of arc ABC is 180 degrees. Next arc, ABD, so start at A, go through B, and finish at D. So that's going to be the same as ABC, 180, plus this 40 more. So the measure of arc ABD is 220 degrees. Next one, arc BC. BC is a minor arc between points B and C. The central angle intercepting that arc is 90 degrees. So the measure of arc BC is 90. And then finally, the last two here on the bottom, arc BAC. So start at B, go through A, and end at C. So there's a couple ways we can do this. And let me explain both. I could, starting here and ending at C, I could just add all the central angles that intercept the arcs along the way. So do 90 plus 140 plus 40. The other way to do it is to recognize that arc BAC is the entire circle except for this minor arc. So I could take 360, the entire circle, and subtract 90 from it. If I do that, 360 minus 90 is 270 degrees. Finally, arc DAB, so we're going to start at D, we're going to go through A, we're going to end at B. So that is the combination of these two central angles that are going to make that arc. So I want to do 140 plus 90. Measure of arc DAB is equal to 230 degrees. Okay, we've talked about arcs, minor, major arcs, what they are, how do we find their measurements. Now let's ask another question. How can we determine if two arcs are congruent to each other? If I ask you to find the measure of arcs MN and PQ, should be able to do that based on what we have just done. The measure of arc MN is equal to the measure of the central angle that intercepts that arc, which is 120 degrees. The measure of arc PQ is equal to the measure of the central angle that intercepts that arc, which is also 120 degrees. So the question, both these arcs measure 120 degrees. Are they congruent? When we talk about congruence, we have to think of like congruence coming from length. Think like rigid motion, congruent polygons, things we've talked about in the past. If I were to take these two arcs and say I could unwrap the circle and I could lay them end to end and I could lay this one straight, would the lengths of those line segments be the same? In this case, the answer would be no, because these two arcs are coming from different sized circles. Therefore, the lengths of these arcs would not be the same, despite having the same measurement in degrees. So the answer, are these two arcs congruent? Despite having the same measurement in degrees, the answer to that question is, in fact, no. Now, in the next slide, I'll show you a theorem that is going to talk about when arcs are congruent and when they are not congruent. All right, the theorem before us here is titled Congruent Central Angles Theorem, and let's just go ahead and read it together. It says that in the same circle or congruent circles, let's stop right there. That's really important. Let's mark that. Same circle or congruent circles. Two minor arcs are congruent if and only if their corresponding central angles are congruent. So this theorem says that arc CB and arc DE are going to be congruent if the central angles are congruent and they come from the same circle. Or maybe they come from two circles, but those circles are congruent. If you think back to the slide we just came from, or rewind it and look at those circles, there were two different circles, but those circles were not congruent circles. One had a radius of 5 and the other had a radius of 4. and that's why those arcs were not congruent. All right, let's do a few examples on the next slide to illustrate this theorem and look at kind of, again, just finalize like what are congruent arcs, what are not congruent arcs, and why. All right, the directions on this slide are the red arcs congruent, and then explain. So in this first circle, question A, we've got a single circle. Okay, so that meets the stipulation of same circle. And then we have two central angles that are both 80 degrees. So these central angles are congruent. Because these central angles are congruent, these arcs are in fact congruent. So the answer here is yes. Reason is same circle and congruent central angles. Let's look at part B. The red arcs are RS and TU, and the question again is same question, are these arcs congruent? The answer here is going to be no. Despite the fact that they are both 90 degrees, these are not congruent arcs because the circles are not congruent. We have circles of different sizes. The radius from Q to S is different than the radius length from Q to U. So those circles are different sizes, therefore those arcs, despite having the same measurement in degrees, are not congruent. And then finally, question C here, we've got arc UV and we've got arc YZ. Now here both arcs are 95 degrees. Okay, so that's good. We can check that box. They've got the same measurement there. This is the key part though. Notice that this tick mark here and this one indicate that these radiuses are the same. Because the radiuses are the same, that means these two circles are the same size, which is the stipulation we didn't meet up here. So are these two arcs congruent? The answer is yes. They are congruent because the circles are congruent. Okay, that concludes this video. I hope you learned a little bit in this video about arcs, how to find their measurements, how to determine if arcs are congruent or not congruent. If you found this video helpful, please give it a thumbs up. And as always, if you want to subscribe to this channel, that would be greatly appreciated and help out the channel for future content. Thank you very much.